All right, so let's talk about arc length reparameterization. So if you, as you may remember, when we introduced the idea of parameterization, we said, look, although your curve is unique, it's perfectly well defined, but the way you parameterize it isn't, right? We can traverse it slowly, we can go backwards, we can do all these different types of things that will lead us to have different expressions describing the same curve. Well, we don't like that. We want to have one expression for one curve. So the way we mitigate that situation is using this process called finding the arc length parameterization of a curve. Okay? So the idea is that instead of using time, which can, you can travel faster or slower, instead of using time to traverse the curve, we're going to use another variable, s, which is related to the arc length of the curve. Okay? So, and the arc length, since it doesn't change, a curve, if it's well defined, it has one arc length, right? So since it's well defined, then it's going to lead us to one and only one parameterization for one curve. Okay? So the process goes a little something like this. First, we find the length function. Now the length function is exactly like the arc length, except for its endpoint. We just put t because we're interested in knowing how far have we gone at time t, where a is some starting time. Okay, it's usually going to be 0, but the basics are we go from a to some time t, and if we solve this integral, it's going to give us an answer something in terms of t, right? Because t is the ending value. It's our upper bound. Okay, and then so we're going to have s equaling some function of t. Well, what we're going to do is solve for t, and now we'll have some function of s, and we're going to replace t in our original parameterization by that function. We can do that because that function equals t. But now what we've essentially done is gotten rid of t, and instead put this new expression in there that's in terms of the arc length, s. Okay? So let's go ahead and do an example to see how it works. So we have a curve here, and we're going to find its arc length parameterization. So first things first, we're going to find r prime, right? It's going to be minus 4 sine 4t, then it's 4 cosine 4t, and 5. Then we're going to find the magnitude of the velocity vector. It's going to be 16, and then I'm not going to do it all out, but sine squared plus cosine squared, but they're all going to cancel each other out. So it's just going to be 16 plus 25. If this is the first time you're seeing this process, go ahead and watch the previous video. Right. So just keep in mind, after we do this, we're going to insert this expression into our integral to find the length function. So this is where it kind of deviates from finding the arc length function, or the arc length. Okay? So here we have square root of 41. So now we're going to go ahead and find s of t. We're going to do it by saying from 0 to some time t. I'm integrating root 41, and then du, because I just want some other variable. I can't do t because t is going to be one of my bounds, but I can use some other variable to integrate. All right, so this is just going to be root 41t. Okay? So s is equal to root 41 times t. So t is equal to s over root 41. Here the process of finding the inverse function was incredibly easy just because the function is just it being multiplied by square root of 41. But sometimes it may be a little more complicated. But the idea is that you have s equals some stuff times t, or something in terms of t, and you're trying to find t equals some stuff in terms of s. And now that we have the expression for t in terms of s, we're going to go ahead and substitute it into the original expression for our curve, and we're going to get r of s, not t, because the whole point was to make this in terms of s, is going to be 4 cosine of, now instead of t, I'm going to write s over root 41, right? And then, I'm sorry, there's no 4. Cosine of s over, cosine of 4s over root 41, sine of 4s over root 41, and we have 5 times s over root 41. And that is our reparameterization according to the arc length. Okay? So it doesn't look simpler because it's not supposed to be simpler, but the pro that it has is that this is the only parameterization in terms of the arc length. So it makes the parameterization a little more unique. Okay? So there you have it.